Hello everyone, welcome to another one of my Leetcode videos. In this one we'll do Leetcode 98, validate binary search tree. So we're basically given a binary search tree or a binary tree, and we need to validate if it is actually a binary search tree or not, right? So let's first understand what are the properties of a valid binary search tree. So everything in the left subtree must be strictly less than the node, right? And everything in the right subtree must be strictly greater than the node. And then both the left and the right subtrees must also be in turn binary search trees, right? So they recursively should possess the same properties. So let's draw it out a bit to understand our approach. So let's say we have a tree like this. Now, over here, our allowable ranges of values like will be negative infinity or whatever the negative max value of integer is to the positive infinity, right? So at the node, we can have any sort, at the root, we can have any sort of values in the subtree that's rooted at this root, right? So let's say this was actually like 5, right? So that means now if once we go down, the subtree that's rooted over here, since it must be strictly less than 5, right? It can only have values from negative infinity to positive 5, right? Or let's say 4 because it has to be strictly less than. And over here, it can only have values from 6 to positive infinity, right? So and this is the whole subtree rooted at here, right? So this entire subtree can only have these values. So now let's say we start from here and we have this range and we go left. Now this subtree must be strictly less than this one. So since this one can only be from -8 to 4, let's say this qualifies. When we go here, it has to be everything that's less than this node, right? So let's say this node was 0, for example, right? So if this node is 0, this node has to be everything from negative infinity to 0 or to -1, right? Because 0 is not included. It has to be strictly less than. And this node over here has to be greater than 0, right? But it cannot be greater than 4, remember, because this whole subtree, the max is only up to 4. So then the allowable ranges of this node will be from 1, right? Because it has to be greater than 0, but it still has to be within this range. So it'll be basically 1 to 4, right? So if this was, let's say, like 6, even though 6 is greater than 0, but it has to be less than 5, so it still has to be within the range that we specify for the root. So then this will be an invalid binary search tree. So basically the idea is that each node will maintain the range and we'll pass down the range as we recurse to the tree. And whenever we go left, we'll take the negative the the whatever the smaller range here is up to the range that's one less than the root. And whenever we go right, we'll take the one more than the root to whatever the upper bound for the allowable root is. And uh, from there we can validate that each node conforms to their allowable range, and if not, we return false. If it does, we'll return true. So let's go ahead and code that and see what that looks like. So as with any recursive problem, we'll need a private function that will tell us whether it's a valid BST, and not only it will take in the root, but it will also take in the ranges, right? So remember we defined our min and max ranges for the node. So for each node, we'll take in the root and the allowable ranges. And from here, we'll just call this recursive function with our root. Our minimum will be integer.min value because we're still at the very top, we still allow all values. So and then our max, according to the same logic, will be integer.max value. Now once we are in the isValid BST function, the first thing is our base case. So our base case is root is null. That means if we are, if we reach like something below the leaves, this is always valid. So we can't have an invalid like null node, right? And if the root is not null, right, then first we should make sure that the root is within the allowable range. So, right, if root is less than min, that means it's out of the range of this min, or if root is greater than max, that means it's also out of range, then we just return false because we know that our root is not conforming to its ranges. And then we just recurse to get the ranges of the left and the right subtree. So we say is valid BST or root dot left, and we'll 1 second compute the min and max for the left, and it'll be or is valid BST root dot right. So now what will be the min and max? So when we go left, the minimum is maintained, right? So whatever the minimum of the current node is, that also has to be minimum of the left subtree, right? So the left subtree can't have a value smaller than is allowable for the current node, right? So when we go left, the min will just be min. And the max when we're going left will be root.val minus 1 because we can't have anything in the left subtree of the root that's greater than or equal to the root. It has to be strictly less than the root. So all the way from min up to root.value minus 1 will be what are the allowable ranges of the left subtree. And then in the right subtree, again, our minimum allowable value is root.val plus 1, right? Because we can't have anything that's smaller than the root in the right subtree. And the maximum allowable value will just be the max of whatever is allowed at the root, right? So if you can't have something higher than what's allowed at the current node, even in the right subtree. So this will be our algorithm, but there is just one edge case here that we need to take care of. It's because this integer.max value here could be actually the value of a node, right? And then when we do like plus 1, that will overflow. So here, instead of int, what we're going to do is we're going to take long instead, right? So that way, when we do plus 1, it won't overflow. And that means whenever we access root.val, we have to just cast it to a long, right? So that way, these won't overflow. So let's try to run this code and see how that does. We have a compile error because you should remove the semicolon here. It's a single or statement. Another compile error, so this is not root, but it should be root.value. Oh, this should be and, not or. So we need both of the left and the right subtrees to be valid. Cool, accepted. Let's submit. Perfect. Thank you so much for watching. I'll see you in the next video. Cheers.